Now, some of you might have challenges asking yourself the question and the differences between accuracy and precision in mathematics. In here, looking at accuracy, this means that you have the number of significant digits that are present in a number. However, when we talk about precision here has to do with looking at a number and how the position of the decimal place of the last significant digit holds, mainly reading from left to right, and so that is how we're able to differentiate between accuracy and precision. Let's say, for example, showing an illustration, we have the first board that is located right here, and we want to hit arrows that are going to be on the board. And so hitting the arrows on this board shows the following result that looks like this. And this result here implies that we have both low accuracy and also we have low precision. Our second case scenario in this case here shows that the arrows are actually hitting at a specific region but pretty much spread out, and this here implies that we have a high accuracy but a very low precision. And this here leads us to the third of the four scenario, where now instead of we having that spread around a region in space, now we have a situation where we have all the four that are clumped in a specific location, and this here that is far away from our end goal, target goal, shows that we have a high precision but a low accuracy. And finally here is our sweet spot goal, where the first case scenario here looks at where all the four arrows are hitting the center, and this here shows a level of a really high accuracy and a high precision. So this here is one illustration that you're going to find on the internet regarding relationship between accuracy and precision. Another case scenario is adding the x and y axis, and so in this case here, where we have this here to be our y-axis, and this y-axis here represents our precision, which is letter P, and it is shown right here for high to down low precision. On the other hand here, we have the other axis here, which is the x-axis, and this x-axis represents our accuracy, where we are going in this case from our low here accuracy to a high accuracy, as is shown above right here from left to right. And looking at precision on the other side, we have going from down to up. So this here is an incredible illustration that you can find on the internet everywhere about relationship between accuracy and precision when it comes to real world application. But how about in mathematics? How is it going to look like using numbers and of course decimal places? Now, given an example with numbers, we have an ammeter with a measurement of its current to be 0.63 amperes, but another ammeter is measuring its current to be 0.631 ampere. And the question here is, which of these two here is showing a better precision, and also which one is showing a better accuracy? And by looking at these here, we recognize that one, for precision, the first one has a lower precision compared to the other measurement, which is the second one, which has a much more higher precision. The reason why it's the case is because the second measure has its last digits after the decimal point to be in the thousandth. However, the first ammeter measurement has its last digit after the decimal point to be placed in the hundredth. Also, in terms of the accuracy,
the first one has a lower accuracy because of the number of significant digits to be just 2 in here. However, for the second ammeter measurement, its significant digits are what? 1, 2, 3. In the case here has 3, which implies that it will have a higher accuracy and also a higher precision for ammeter 2 compared to ammeter 1, which has a lower precision and accuracy. In here we have an example with numbers, and we're going to compare sidewalk A numbers, and then we're going to compare sidewalk B numbers, and then we're going to compare both sidewalk A and sidewalk B based on long and also thickness. So first, looking at sidewalk A, comparing these two numbers, looking at specifically what is the precise number. This here shows us that for sidewalk A, we don't have any decimal place in here because there is no decimal point. However, for sidewalk A's thickness, which is 0.5, 5 is placed as the 10th, which is the last digit that is after the decimal point. Therefore, this here is more precise than 240. For the accuracy, when it comes to what is the significant digits that are present here for sidewalk A long measurement, this shows that we have 2 significant digits. However, this here has what? Just 1 significant digit. Therefore, our 240 here is more accurate than that of the number, which is 0.5. However, for sidewalk B, looking at 240.3 meters long versus that of 1.5 meters thick, comparing those two numbers based on precision, we notice that for the decimal place here, we have 1, which is in this case for long to be in the 10th, as well as that of our B thickness to be significant digit that is the last after the decimal point to be also 10th. Therefore, both of them are equally precise. However, when we are moving into the accuracy part, the accuracy shows us a different story here, where in here for the long measurement, we have our 240 to have 1, 2, 3.3. In this case 4, we have 4 significant digits. However, for the thickness, we just have how many here? Just 2. Therefore, our 240.3 has a more accuracy compared to that of our value 1.5. Now, looking at the long, comparing sidewalk A to that of sidewalk B, looking at precision, we recognize that the first one here doesn't have any decimal place in here. However, this has a decimal place, the last digits to be 3 as the 10th position. Therefore, our 240.3 is more precise than that of our 240. Now, in terms of accuracy, we can also deduce that because our sidewalk B has 4 significant digits overall, however, our sidewalk A long has 2 significant digits. This here also shows us here that our 240.3 is more accurate than that of our 240 in terms of the length. Now, on the other side, looking at the thickness in terms of comparing our 0.5 meters for A to that of sidewalk B 1.5, looking at the precision, which is the last digit after the decimal point, in here we recognize that both of them, because they are both placed at the 10th, they are equally precise. So in here we can say that our 0.5 is equally precise as that of 1.5. However, in terms of looking at the accuracy, this is where things get different here, because do we really count our 0? Not really. In terms of it being significant, it is not significant at all. Therefore, we are going to be counting just the 5 as one significant digit, as we talked about over here. However, our sidewalk B has 2 significant digits. Therefore, our 1.5 is more accurate than that of 0.5 in terms of the thickness. So I hope you found this really informative in terms of accuracy and how to apply that to numbers as well as precision, and this incredible chart, I must say, that you may have come across, and how this here will make you to not only understand how accuracy gets you closer to an actual value. However, for your precision here, it is in terms of how much more specific is your numbers as you are performing your experiment. So hope you found this really informative. Hit a comment down below, let me hear your thought about this. By that way we can talk to you soon. Stay smart as always and believe in yourselves.